For question number 1, part B, we need to again try to solve our equation using a variety of strategies. Some people would like to look inside, which is another way of saying guess and check, to figure out this problem, but I personally find the easiest way of solving this problem to involve undoing, canceling out some of the operations in order to get some of the variables solved. The best way to do that would be to start by trying to get rid of the square root. The opposite of a square root is a square, so I would start by squaring both sides of the equation. By squaring the left-hand side, the square will cancel the root, leaving me with x plus 2. And then on the right side of the equation, x squared is really just going to be x squared. When we see the rest of what we're left with, hopefully it occurs to us that we have an x squared and some other terms that could be moved over to the right-hand side to join it. If I move those two terms, x plus 2, to the right-hand side, that would give me x squared minus x minus 2, and now left over on the left-hand side would be 0. The reason I did that is so now I can try to factor the right-hand side. Now I've got a term, or a trinomial, and since it's easily factorable using a diamond problem, I'm going to try to see what's going to work here. To set up our diamond problem, we'll need numbers that multiply to -2 and add up to -1. The numbers that would multiply, it means to multiply to -2, but also add up to -1. So when I think about those numbers, the only thing that would really work is -2 and +1, since they both multiply and add. If I have those numbers now, since we don't have a coefficient next to x squared, the easiest way to factor is to simply include in our parentheses the letters x in the first spaces, since x times x takes me back to x squared. And then, of course, we'll arrange our terms from the diamond, -2 and +1. So our factors are x minus 2, x plus 1. To solve each of those factors, we then need to utilize what we call the zero product property. In other words, we take each of the factors and equal it to 0. So x minus 2 equals 0 and x plus 1 equals 0. If I solve the first one, x minus 2 equals 0, I would add 2 to both sides, and I'd get x equals +2. If I use the second one by subtracting 1 to both sides, I'd get x equals -1. But we notice, of course, that I just got 2 answers, and yet there's only one solution space. That's because with many square root problems, there exists what we call extraneous solutions. Solutions that come out when you're solving, but when you plug back into the equation, don't make very much sense at all. If I take, for instance, this -1 and plug it back into the equation, I'd have the square root of -1 plus 2 equals -1. Now, if I'm taking the square root of -1 plus 2, which is really 1, the square root of 1 is not going to be -1. So that means this rule, or this -1, this input, violates a rule that we can't break. We can't have a negative output of a square root. Since -1 violates a rule, we call it an extraneous solution. And if a solution is extraneous, that means we do not report it as one of our valid solutions. So that means since +2 does plug in successfully, 2 plus 2 is 4, square root of 4 is 2, so that one works. We say 2 is our only solution. We never write in an extraneous solution. We only include the solution that does work in the original equation.